E-bike manufacturers don't want you to know that their maintenance-free claims are complete lies. What if I told you that the bike they promise will run for years without service will be completely dead after just 6 months of normal use? That's not an exaggeration. 6 months and you'll understand why repair shops are packed with expensive e-bikes that owners thought were bulletproof. Imagine dropping $5,000 on what looks like the perfect commuter machine, only to discover it's designed by people who clearly never maintained anything electronic. In this video, I'm counting down the 15 most critical maintenance tasks that will keep your e-bike running forever. And trust me, number 1 might shock you. It takes 30 seconds but prevents more failures than everything else combined. Stick with me to the end, because this isn't just maintenance advice. It's your financial survival guide to avoid the expensive disasters disguised as low-maintenance e-bikes. Number 15. Protecting electrical components from the elements. Starting our countdown at number 15, protecting your motor and electrical components from water damage seems obvious, but most riders get this completely wrong. The number 1 mistake is using high-pressure hoses or power washers that force water into sensitive electrical connections, motor housings, and bearing assemblies. Water intrusion doesn't just cause immediate failures, it creates long-term corrosion that slowly destroys electrical connections and motor components. Once water gets into the motor housing, it can cause bearing rust, electrical shorts, and permanent damage that requires complete motor replacement. The correct approach is surprisingly simple. Clean the motor housing with a dry or slightly damp cloth only. For added protection against splash water and extreme cold, use specialized neoprene covers on both the motor and battery. These covers create a barrier against moisture while allowing heat dissipation. This might seem like basic advice, but emergency repair shops report that water damage accounts for nearly 30% of all motor failures. The cost to replace a motor ranges from $800 to $2,000, making this simple protection step worth thousands in avoided repairs. Number 14. Monthly battery contact cleaning. Number 14 focuses on a maintenance step that most riders never even think about: cleaning battery contacts. These electrical connection points between your battery and the bike system accumulate dirt, moisture, and oxidation over time, creating resistance that reduces power transfer efficiency. Dirty contacts don't just reduce performance, they create heat buildup that can damage both the battery and the bike's electrical system. This heat generation also reduces battery life by forcing the cells to work harder to deliver the same power output. The cleaning process is straightforward but critical. Remove the battery from the bike and inspect both the battery contacts and the corresponding connection points on the bike. Use a clean, dry cloth to wipe away any visible dirt or corrosion. For stubborn buildup, a small amount of electrical contact cleaner on a cloth can remove oxidation. Clean contacts ensure maximum power transfer efficiency, extend battery life, and prevent the costly heating issues that can damage expensive electrical components. This 5-minute monthly task can prevent hundreds of dollars in electrical system repairs. Number 13. Suspension system checks and adjustments. Number 13 brings us to suspension system maintenance, which becomes even more critical on e-bikes due to their increased weight and higher speeds. Most riders set their suspension once and forget about it, but the additional mass of the motor and battery requires regular adjustment to maintain optimal performance. Under-adjusted suspension on an e-bike creates a harsh ride that transmits more shock to the frame and components. Over-adjusted suspension reduces control and can cause the bike to feel unstable at higher speeds. Both scenarios accelerate wear on other components and reduce safety. Proper suspension setup involves adjusting both compression and rebound settings based on rider weight plus the bike's additional mass. The suspension should compress about 25% of its travel when you sit on the bike in normal riding position. Rebound should be set so the suspension returns to neutral position smoothly without bouncing. For riders who frequently carry cargo or passengers, suspension settings need adjustment based on total load. This dynamic adjustment prevents bottoming out and maintains control characteristics that keep the bike stable and safe. Number 12. Comprehensive loose parts inspection. Number 12 addresses a problem unique to e-bikes: Constant vibration from the motor combined with higher speeds causes components to loosen much faster than on traditional bikes. The motor's vibration literally shakes bolts and connections loose over time, creating potential safety hazards and mechanical failures. A systematic approach to checking loose parts involves inspecting all critical connection points weekly. This includes stem bolts, seat post clamps, brake mounting bolts, derailleur hangers, and motor mounting hardware. Each component should be checked for proper torque specifications using appropriate tools. The stakes are higher on e-bikes because loose components can fail catastrophically at higher speeds. A loose stem bolt that might just create wobbling on a traditional bike can cause complete loss of steering control at 28 miles per hour on a Class 3 e-bike. Professional mechanics report that preventive tightening prevents 90% of mechanical failures related to loose components. This weekly check takes just 10 minutes but prevents dangerous situations and costly repairs from components that vibrate loose during operation. Before we continue this countdown, make sure you're subscribed and hit that notification bell. The remaining tasks on this list become increasingly critical, and missing any of them could cost you thousands in repairs or replacement. Number 11, bearing maintenance and greasing. Number 11 focuses on bearing maintenance, which becomes exponentially more important on e-bikes due to the constant stress from motor torque and increased weight. Bearings in the bottom bracket, wheel hubs, and headset experience much higher loads than on traditional bikes, requiring more frequent attention. Dry or contaminated bearings create friction that wastes battery power and generates heat that can cause permanent bearing damage. Once bearings start wearing, the deterioration accelerates rapidly, leading to expensive component replacement rather than simple maintenance. Proper bearing maintenance involves regular inspection for play or roughness in rotation, followed by cleaning and re-greasing as needed. The frequency depends on riding conditions, but annual bearing service represents the minimum for most e-bike applications. Professional bearing service typically costs $50 to $100 per component, but prevents bearing replacement that can cost $200 to $500 per wheel or bottom bracket. The performance improvement from properly maintained bearings also increases efficiency and battery range. Number 10, derailleur adjustment and fine-tuning. Number 10 covers derailleur adjustment, which becomes critical on mid-drive e-bikes where the motor puts enormous stress on the entire drivetrain. Poor shifting doesn't just affect performance. It can cause chain derailment that damages expensive components or creates dangerous riding conditions. The additional torque from e-bike motors accelerates wear on derailleur components and can cause adjustments to drift over time. What starts as slightly imprecise shifting quickly becomes chain skipping, missed shifts, or complete derailment under power. Proper derailleur adjustment involves setting limit screws to prevent the chain from falling off either end of the cassette, then fine-tuning the indexing so each shift occurs precisely and smoothly. The barrel adjuster provides ongoing fine-tuning capability as cables stretch and components wear. For mid-drive e-bikes especially, perfect derailleur adjustment is non-negotiable. Chain derailment under motor power can damage the chain, cassette, derailleur, and even the frame. Professional adjustment costs $50 to $75 but prevents component damage that can exceed $500. Number 9, rotor and brake pad inspection. Number 9 addresses brake system inspection, which takes on life or death importance on e-bikes that are heavier and faster than traditional bikes. Brake failure at 28 miles per hour with a 70-pound bike creates exponentially more dangerous situations than brake issues on lighter, slower traditional bikes. Brake pad wear accelerates dramatically on e-bikes due to increased weight and higher average speeds. Worn pads don't just reduce stopping power, they can damage rotors that cost $50 to $100 each to replace. Complete brake pad replacement typically costs $40 to $60, while rotor replacement adds another $100 to $200. Visual inspection reveals pad wear, but the key indicator is pad thickness. When brake pad material wears down to the thickness of a mechanical pencil lead, replacement becomes urgent. Rotors should be inspected for discoloration, warping, or scoring that indicates overheating or contamination. The complexity varies between mechanical and hydraulic systems. Mechanical brakes are easier to service at home, but require more frequent adjustment. Hydraulic brakes offer superior performance, but need professional service for bleeding and major repairs. Both systems demand regular attention to maintain the stopping power essential for e-bike safety. Number 8. Spoke tension monitoring. Number 8 reveals a hidden weakness specific to e-bikes: spoke tension problems caused by motor torque and increased weight. Hub motor e-bikes subject wheels to unique stresses that can cause spokes to loosen progressively, leading to wheel failure that can cause serious accidents. Loose spokes create an untrue wheel that wobbles during riding, but the real danger comes from progressive spoke loosening that can cause sudden wheel collapse. The constant torque from hub motors combined with the bike's extra weight creates stress patterns that traditional bicycle wheels weren't designed to handle. Checking spoke tension involves plucking each spoke like a guitar string and listening for uniform tone, or squeezing pairs of spokes to feel for consistent tension. Loose spokes have noticeably lower pitch or feel much softer than properly tensioned neighbors. While checking spoke tension is straightforward, wheel truing requires specialized tools and expertise. Professional wheel truing costs $50 to $75, but prevents wheel replacement that can cost $200 to $500. More importantly, it prevents the safety hazard of wheel failure during riding. Number 7. Strategic storage protocols. Number 7 covers battery storage, which determines whether your expensive battery pack lasts 2 years or 10 years. The storage charge level and environmental conditions during inactive periods have massive impact on long-term battery health and capacity retention. Most riders store batteries either completely full or completely empty, both of which cause irreversible chemical damage. Full batteries suffer from high-voltage stress that degrades cell chemistry. Empty batteries can enter deep discharge states that make them unrecoverable. The optimal storage charge level is between 50% and 60% of capacity, which minimizes chemical stress while providing buffer against self-discharge. Some manufacturers recommend higher levels around 75% to 80% as protection against natural discharge over time. Storage environment matters just as much as charge level. The ideal temperature range is 50 to 77 degrees Fahrenheit in a dry location away from direct sunlight. Sub-zero temperatures cause permanent battery damage, while high temperatures accelerate chemical degradation. Proper storage can extend battery life from 3 to 4 years to 8 to 10 years, representing savings of $500 to $1,500 in replacement costs. Monthly charge level checks during storage prevent deep discharge that can render expensive batteries completely unusable. Number 6. Payload respect and weight management. Number 6 addresses something most riders ignore completely: staying within weight limits and understanding how payload affects every component on the bike. Exceeding weight capacity doesn't just void warranties. It accelerates wear on every system and can cause dangerous component failures. E-bikes have specific weight limits that include rider weight plus cargo, but many riders treat these as suggestions rather than engineering requirements. The motor, battery, brakes, wheels, and frame are all designed around maximum load specifications. Overloading strains the motor and reduces battery efficiency, forcing both systems to work harder and wear faster. Brakes experience increased heat buildup that can cause fade or component damage. Wheels and spokes face higher stress that can lead to failure. Staying within weight limits isn't just about component protection. It's about maintaining the bike's design safety characteristics. An overloaded e-bike handles differently, stops more slowly, and can become unstable in emergency situations. Understanding your bike's payload capacity and respecting those limits extends component life, maintains safety margins, and prevents expensive repairs from overloaded systems. This knowledge costs nothing but saves thousands in premature component replacement. Number 5. Intelligent charging strategies. Number 5 reveals the charging habits that separate batteries that last 3 years from those that last 10 years. How and when you charge has more impact on battery longevity than any other single factor. Yet most riders follow charging patterns that actively destroy their investment. The first critical rule is using only the original charger or manufacturer-approved alternatives. Incompatible chargers can cause overheating, cell damage, and fire hazards that can destroy not just the battery but your home. This isn't paranoia. It's documented safety protocol. Charging location matters enormously for safety. Always charge in well-ventilated areas away from flammable materials on hard, non-conductive surfaces like concrete. Allow the battery to cool for at least 30 minutes after riding before connecting the charger. Heat during charging accelerates degradation and increases fire risk. The optimal charging strategy balances convenience with battery chemistry. Daily commuters should charge after every ride to avoid range anxiety, but shouldn't leave batteries at 100% charge for extended periods. The technical best practice involves maintaining charge between 20% and 80% for maximum longevity. Modern battery management systems prevent overcharging, but they can't eliminate the chemical stress of high-voltage storage. Understanding this balance allows riders to optimize their charging habits for both convenience and battery life, potentially extending battery lifespan by 200 to 300%. Number 4. Drivetrain deep cleaning and lubrication. Number 4 focuses on drivetrain maintenance, which becomes exponentially more critical on e-bikes where motor power amplifies every inefficiency. A dirty, poorly lubricated chain doesn't just affect performance, it can cause accelerated wear that destroys expensive drivetrain components. The e-bike motor magnifies drivetrain stress tremendously, especially on mid-drive systems where motor power flows through the chain and gears. Debris and old lubricant create friction that wastes battery power and generates heat that accelerates component wear. Proper cleaning requires complete removal of old lubricant and contaminants before applying fresh lubricant. Turn off the bike and remove the battery for safety. Apply bike-specific degreaser to the chain and drivetrain components. Scrub with stiff brushes, then rinse carefully, avoiding bearings and electrical components. Lubrication type matters based on riding conditions. Wet lubricants work best in rainy or muddy conditions, while dry lubricants suit dusty environments. Apply sparingly to each chain link, then wipe excess to prevent dirt attraction. Professional data shows that proper drivetrain maintenance can extend chain life from 1,000 miles to 3,000 plus miles, and cassette life from 3,000 miles to 10,000 plus miles. This represents hundreds of dollars in prevented component replacement costs while maintaining peak efficiency and battery range. Number 3, comprehensive brake system management. Number 3 addresses brake maintenance, which literally keeps you alive on a machine that can exceed 28 miles per hour and weigh over 70 pounds. Brake failure on an e-bike creates exponentially more dangerous situations than on traditional bikes, making this maintenance absolutely non-negotiable. E-bike brake systems face much higher stress than traditional bike brakes due to increased weight and higher average speeds. This stress manifests as faster pad wear, increased heat buildup, and accelerated component fatigue that can cause sudden failure. Visual inspection provides early warning of problems. Check brake pad thickness regularly. When pad material reaches pencil lead thickness, replacement becomes urgent. Inspect rotors for discoloration, warping, or scoring that indicates overheating or contamination. The critical safety rule for disc brakes: never pull brake levers when wheels are removed. This can lock pads together or push hydraulic pistons out of their housing, requiring expensive professional repair. Hydraulic brake systems offer superior performance, but require professional maintenance for bleeding and major repairs. Mechanical systems are easier to service at home, but need more frequent adjustments. Both demand regular attention to maintain stopping power that can prevent serious accidents. Number 2, tire pressure optimization. Number 2 might seem basic, but tire pressure optimization affects every aspect of e-bike performance, safety, and component longevity. Incorrect pressure doesn't just affect ride quality, it dramatically impacts battery range, tire wear, and safety margins. Underinflated tires increase rolling resistance, forcing the motor to work harder and drain batteries faster. This effect is magnified on e-bikes due to their higher weight and power assistance. Studies show that 20% low pressure can reduce range by 15 to 25%. Overinflated tires reduce contact patch and traction, especially dangerous on heavy e-bikes at higher speeds. They also transmit more road shock to the frame and components, accelerating wear throughout the system. Different e-bike types require specific pressure ranges. Road e-bikes need 80 to 130 pounds per square inch for maximum efficiency. Commuter bikes balance efficiency and comfort at 50 to 70 psi. Mountain e-bikes use 25 to 45 psi for traction. Fat tire bikes operate at 15 to 30 psi for flotation and grip. Proper pressure maintenance requires checking before every ride, as tires naturally lose pressure over time. This simple habit maximizes battery range, prevents pinch flats, ensures optimal handling, and extends tire life. The pressure gauge is your most important maintenance tool. Number 1. Battery health mastery. Taking the number 1 position, battery health management is the single most critical factor determining your e-bike's longevity and value retention. The battery represents 30 to 50% of your bike's cost, and proper care can extend its life from 3 years to 10 plus years, representing thousands of dollars in savings. Battery chemistry follows inflexible rules that can't be ignored without consequences. Lithium-ion cells degrade through 2 primary mechanisms: cycle aging from charge-discharge cycles and calendar aging from time and storage conditions. Understanding these mechanisms allows strategic management. The most critical insight is that batteries stored at high charge levels, 90 to 100%, experience accelerated degradation even when not being used. This chemical stress occurs continuously, making it more damaging than actual riding in many cases. The optimal strategy balances practical needs with battery chemistry. Charge after every ride for daily use, but avoid leaving batteries at 100% for extended periods. When possible, maintain charge between 20 and 80% for maximum longevity. Temperature management is equally critical. Never charge immediately after riding. Allow 30 minutes cooling time. Store in climate-controlled environments between 50 and 77 degrees Fahrenheit. Avoid sub-zero temperatures that cause permanent damage. Monthly monitoring during storage prevents deep discharge that can render batteries unrecoverable. This simple attention can extend battery life by 300 to 400%, representing the difference between replacement every 3 years versus every 10 plus years. Now you know how to keep your e-bike running forever, but what about electric motorcycles? Some are engineering masterpieces while others are expensive disasters waiting to happen. Check out my video, 4 worst and 5 best electric motorcycles to own, to see which ones will drain your wallet.